Hello students, in the last class we discussed what a trigonometric equation is and how to write general solution for some specific equations. In this lecture we are going to discuss different ways which we can use while solving a trigonometric equation. There are so many ways which we can utilize, likewise factorizing, using transformation formulae, using boundness of the function, as well as substitution. So without any further ado, let's get started. So the first thing which we are going to discuss now is how trigonometric formulas, transformation formulas can be used to solve a trigonometric equation. Just have a look on this one. Cosine 3x plus sine 2x minus sine 4x is equals to 0. Just have a look on its last two term. Can we apply sine c minus sine d over there? By applying sine c minus sine d, we get 2 times cosine c plus d by 2, which become cosine 3x times sine c minus d by 2. That will be sine negative x. Now it should be equals to 0. Remember, sine negative theta is equals to negative sine theta. We may take out cosine 3x as a common. So the terms we are left with is 1 minus 2 sine x. It is equals to 0. Now what we did, we convert sum of one or more trigonometric function into their product. Now we have product of two trigonometric function and result is a 0. So either cosine 3x should be equals to 0 or 1 minus 2 sin x should take a value equals to 0. So if cosine 3x is equals to 0, we end up getting values of 3x. So the general solution of cosine 3x is equals to 0 is given by 3x is equals to n pi plus pi by 2. Similarly, for 1 minus 2 sin x, we may write down there sin x should be equals to 1 by 2. And writing the solution for sin x is equals to 1 by 2 is x is equals to m pi plus negative 1 to the power m into alpha. Alpha should be in principal branch. It should belongs to principal branch only. And when sin x will give you 1 by 2, it will give you 1 by 2 at x is equals to pi by 6. So there we go. Now we have two different set of values. If particular solution is asked in particular range, then we may start putting different values of m and n. All right. Now let me take another one. In this one, we need to check which one of the option is right. We need to find general solution for this trigonometric equation. We have two sine terms on left hand side as well as on right hand side. Now, please focus on their angle. Does their sum or difference make any sense? If you try to add their argument x and 5x as well as 2x with 4x, their sums are equal. So we are free to apply sine c plus sine d on left hand side as well as on right hand side. So sine c plus sine d will give us 2 sine c plus d by 2, which is sine 3x times sine c minus d by 2, which give you sine negative 2x. Now it should be equals to, apply the same formula on the right hand side, we get 2 sine c plus d by 2, which is sine 3x times sine 3 c minus d by 2. That will give you sine negative x. From there, you are free to cancel this constant, but beware with this sine 3x. Do not cancel it out. So rather than you need to take out sine 3x as a common. So sine 3x time we have sine negative 2x minus sine negative x. That should be equals to 0. Now apply sine negative theta is actually a theta, negative sine theta. So we get sine 3x times sine x minus sine 2x. Sine x minus sine 2x. You are free to apply further sine c minus sine d inside this bracket because it will attract to different opinion or conclusion, you may call it. Either sine 3x should be equals to 0 or we have another situation. It is sine x is equals to sine 2x. Now you have varieties of way to solve relation number 2. You may either apply sine c minus sine d or you may even open up sine 2x, which is 2 sin x cosine x. There is another way by which you can write the solution for sin 2x is equals to sin x. And it is, you may consider your 2x as a theta and x being alpha there. So we have 2x is equals to n pi plus negative 1 to the power n into alpha. Alpha is x right there. Similarly, for sine 3x is equals to 0, we have 3x is equals to n m pi, and from there I'll get x is equals to m pi by 3. X is equals to m pi by 3. Now you may check which of the following option is correct. Let me take another one. Sine 6x over sine x is equals to a particular function. Remember, before you start solving this question, you need to make a good note there that sin x cannot be equals to 0, which says that you cannot take values of x which are integral multiple of y. Now, for the purpose or for the sake of simplicity, we may cross multiply this expression by assuming that x cannot take the values equals to n pi. So there we go. We have sine 6x is equals to 8, right? 8 as a 2 times 2 times 2, and then we have this sine x, then cosine x is there, then we have a cosine 2x, and later on we have cosine 4x. Now try to look at the terms very closely which are on the left hand side of expression. Your 2 sin x cosine x will become, it will become sine 2x, it will become sine 2x. Now try to take these three terms collectively, 2 sine 2x and cosine 2x. What this three term will give you? This three term will give you sine 4x in a result. Another 2 is there. So along with this 2, sine 4x and cosine 4x. This is equals to sine 8x. So there we go. We need to solve this expression where sine 6x is equals to sine 8x. Either you may use the previous approach by assigning 8x to theta, 6x to alpha. Or if you don't want it, then you may shift your sine 6x on the other side, and eventually you have this expression. Sine 8x minus sine 6x is equals to 0. It implies 2 cosine c plus d by 2, which is cosine 7x, into sine c minus d by 2, which is sine x, is equals to 0. Now again, two conclusion can be drawn from there. Either cosine 7x should be equals to 0, or we may say that sine x should be equals to 0. If sine x is 0, that means your x should be integral multiple of y, which is not possible, because according to that question, sin x is there in denominator. So this solution is not acceptable. Now what about cosine 7x is equals to 0? For that one, we may write down that x is equals to n pi plus pi by 2 over 7. There we go. So this will be the only solution of this equation. Now let me take the another one. Here we have a terms in multiplication. So first of all, we need to think about how we can get rid of this square thing. If you are good in writing down multiple and some multiple angles, then I'm sure you know cosine 2x can be written as 2 cosine square x minus 1. And if you want to express it in terms of sign, then we have another one. It is 1 minus 2 sine square x. If we are using cosine 2x is 2 cosine square x minus 1, then what can be done? We may multiply the whole expression with the 2. So eventually I end up getting 2 cosine square x plus 2 cosine square x 2x plus 2 cosine square x 3x plus 2 cosine square x 4x. And that is equals to what? That is equals to 4. Now from there, do needful substitution. 2 cosine square theta is as good as writing cosine 2x plus 1. Similarly, for the another one, we may write it as a cosine 4x plus 1. Third expression can be reduced to cosine 6x plus 1. Similarly, the fourth one can be written as cosine 8x plus 1. Now that should be equals to 4. This 1 plus 1 plus 1 plus 1 will get cancelled out. Now You may just pair this term according to their argument. Cosine 2x with cosine 8x, and I'm associating cosine 4x with cosine 6x. Now apply cosine c plus cosine d there. This will give you cosine c plus d by 2 times cosine c minus d by 2, which will give you cosine 3x. Now apply the same thing between cosine 4x and cosine 6x. You will get 2 cosine c plus d by 2 times cosine c minus d by 2. There we go. Now, once you take out this cosine 5x as a common, along with this 2, we have cosine 3x plus cosine x is equals to 0. If you want, then you may apply cosine c plus cosine d again. So there we go. We end up getting 4 cosine 5x into cosine 2x into cosine x is equals to 0. Cosine x is equals to 0. Now you know how to write down their general solutions. All right, now last one of the day, root 3 cosine theta minus 3 sine theta is equals to 4 sine 2 theta into cosine 3 theta. So what I'm going there, I will not disturb my left hand side and will move to the right hand side. Then I'll break this 4 as a 2 into 2. So I'll get 2 times 2 sine theta cosine theta will give us sine a plus b plus sine a minus b. Sine a minus b will be sine negative theta. So there we go. We have negative root 3 cosine theta, excuse me. Negative 3 sine theta is there. Now 2 times negative sine theta, agar I say, if we are bringing this term on the left hand side of this expression, it will be plus 2 sine theta. And there we go, it is equals to 2 sine 5 theta. Now divide this expression with a 2, we'll get root 3 over 2 cosine theta minus sine theta over 2. And that should be equals to sine 5 theta. Sine 5 theta. Now you may read your root 3 by 2 as a sine 60 degree or cosine 30 degree. If you read root 3 by 2 as a sine 60 degree, then remember your 1 by 2 along with this sine theta will become cosine 60. Now apply your trigonometric formulas again. This expression is nothing but sine pi by 3 minus theta is equals to sine 5 theta. There you go. I hope this lecture is useful to you. We'll be discussing more challenging problem in the next class.